Greetings, fellow students. So let's go over the concepts of the test, I guess. Not really the problems, because that would be illegal. First, basic things that you need to know. You seriously need to know the definition of a derivative. And that means what a derivative tells you. So, it's slope of a line to a certain graph, tangent to that graph, and then you also have what the beginning definitions of derivative was, and that's the limit of h as it approaches 0 of f of x plus that small number h minus f of x then over h, right? And then later on we replace it with numbers, and if you can give me that equation, I could give you the derivative or the original function, and you want to be able to do that. Then you also want to be able to do the whole going from f to f prime and then going backwards, because you could also do that, and you need to do that. So what does f prime tell you about f? It tells you the maximums and the minimums, if it's increasing, if it's decreasing. You want to be able to find the critical points and know how to find them. You also want to know a lot about f double prime, which tells you stuff about f prime, but also tells you stuff about the original function f. And you want to be able to go through that loop from f to f prime to f double prime, then going backwards, skipping one of them with as much ease as you can, because that is a skill that you also need to show that you know how to do on the test. Of course, we're assuming that you know how to take the second derivative and you know how to take a first derivative. Second derivative, you're just doing the first derivative twice. Now, you want to, other than the equations themselves, you want to look at the graph and see if it's f, what does that tell you about f prime? If it's f prime, what does that tell you about f? But you also want to look at tables that have 1, 2, 3, and let's say that's f prime, and what does that table tell you about f? You want to be able to do that. I think that appears twice or something. So it's important to see a graph, go to f prime or to f, see a table, do the same, see an equation, do the same. And then that would directly relate to physics, with the whole position, going to velocity, going to acceleration, which is f prime and f double prime. And you want to make sure that you know the distinction between displacement and distance, because they're not the same, they're very different. Displacement is just the net change in your position. However, distance is the actual how much you travel. So distance, if you you're on a certain line and you go from point A to point B, and then you go backwards, well, you have a net displacement. You have a displacement of 0 because you went and then you came back. So the change in your position is 0, but how much distance you traveled is actually 2 times the distance from A to B. And you want to be able to find distance when you have an x equation. X of t is equal to an equation. So you could just go back and review how we did those problems, and that should be good enough. You also want to know integrals, because that's also part of calculus. What are the just antiderivatives? And you want to know the whole ln, natural log, the e, the basic trigonometric functions. Really, you don't need to. A lot of the stuff that we've done in the past few days don't really appear. So It shouldn't be a problem to you, although you should probably know it, for future reference. You want to know the whole f average equation, which is 1 over b minus a. We're taking the area of a to b of f. That's an important equation that you will be using. You will be using it. Then theorems. You've got the fundamental theorem of calculus, and then you've got the IVT, which you want to know these two. It's called the fundamental theorem of calculus for a reason. It's an adjective which describes the theorem, saying that it's mucho importante. And then you also need to know the whole tools of derivatives and integrals, and then the chain rule, which is just if you have a function inside a function inside a function, you wanna be able to take the derivative of that. You start with the outside, then you go in. Take the derivative of what's inside, then you go in even more, and you take the derivative of that until you have nothing to take the derivative of, and then you can solve whatever problem it is. There's one confusing thing, and that's when they give you the whole g is the integral of f. Well, what does that mean? And I would suggest writing it down in English words. And so let's say you take the derivative of g, so g prime is f, right? So what that means in actual words is that the function f is the derivative of g. So if I tell you this is f, this is the derivative of g. Okay, it is equal to g prime. You want to do that to make sure that you go over that kind of problem. One last thing that I'm going to mention is the whole continuous versus differentiable ideas. If something is differentiable, then it is continuous. Okay? Because for you to take the derivative of something, you need a point at that, let's say a. You need a point to exist at a. Right? So differentiable means that the function must be continuous, but it doesn't go the other way around. Because, this is continuous, but can you find the derivative of that point? No, you can't, because you're approaching this number a, and you have a certain slope, and then suddenly, literally at one single point, you change from, let's say, a -2 to a slope of 2, right? And that just is not differentiable. So, again, differentiability means it is continuous. However, continuous does not necessarily mean that it is differentiable. That's a broad overview. You could, if you've written things down, you should probably write things down, then go back and see what you need to know, what you need to go over. It's a calculus test, so you should, be prepared to see some calculus ideas on that test. That's it for today. Thank you.